Okay, so let's advance this Holocene story a little bit by adding other pieces of caveats that we will need. So we'll find a lot of stories like this, which are obviously evidences based on proxies and archaeological evidences. So if we look at the African region, which is generally the region that has been the biggest focus of human evolution through time. So we are looking here at the rainfall before 8500 BCE, which we implied already in the warm and wet periods after the end of the last glaciation 10,000 years ago. So you can see that there are basically regions which had less than 50 millimeters of rain and very few green rainy regions here before 8500 BCE, and the known civilizations or settlements of human beings are mostly along this Nile River here. This is the current day Sudan and Egypt boundary here, but without worrying about that, you see that settlements are obviously around sources of water, and we will come back to see what the status of agriculture was at this point. And the precessional forcing and related greening of the Africa is associated with the warm Holocene climatic optimum that we talked about in the previous podcast. So 8500 to 17,000 before Common Era. You can see that rainfall patterns have changed, the same region, but you have many more regions here with rainfall maybe even reaching more than 300 millimeters of rain, which begins to give you water resources quite far away from the Nile. You can see the spread of the rainfall here. There's a thin band of more than 150 millimeters down here, more than 300, more than 450 millimeters per year over here. And you can see that the settlements have now spread quite far into the western regions of northern Africa in what is now the modern Sahara region. Obviously, water resources are likely to have driven these explorations, and we will look at population estimates later on, but generally you can assume that maybe climate and availability of water was a driver here, and this continues into 7000 to 5300 BCE as well, and maybe there is an increase in the number of settlements, so one has to worry about anthropological views and agricultural suitability, habitat suitability, and other issues to see whether the expansions and multiplications and maybe splitting or merging of settlements was related to the rainfall as well. And we also have to come back later on about how refugia may bring together people and lead to interactions that are different than when they spread out like this and become independent. And by 5300 BCE there is a cooling and drying, so you can see the rainfall here almost completely disappears again, and you are back into this Sahel band to the south, with some rainfall still remaining here higher than before 8500 BCE, and the settlements then again began to congregate around the Nile River, with some additional settlements over here that are not there in this time period. So obviously you can assume that climate played a role in this, and we will see many such examples throughout, and keep asking the question about the role of the climate versus intrinsic social structural changes, governance changes, militarizations, and other things. And this is another famous example, Mohenjo-Daro Harappa period, going between thousands of years ago now. We are not somewhere between 3500 years to 2,000 years or so, the whole year rainfall and summer rainfall, obviously the monsoon region, most of the rainfall, annual rainfall falls during the southwest monsoon, as happens in the current period as well. So there was a drier period coming out of the last glacial maximum, and then the warm periods began to produce rain with some variability, and the Holocene climatic optimum produced rainfall that were significantly larger than before. So here we are crossing 1,000 millimeters, which is a huge amount of rain. And then precessional forcing, and there is also some volcanic eruptions involved. You can see that the Harappan period boomed here. They were quite organized around urban centers, trading, agriculture, granaries, and so on. So they were very active during this period, and then came the multi-century dry period here that is associated with the 4200 year event that we have talked about before, and the general collapse of the monsoon rainfall. So the question asked before is whether human societies innovated when they had these kind of perturbations, like water harvesting structures, water transportation structures, aqueducts. In the Andes, you would have had fog harvesting and other approaches to save water. And was the decline slow and steady, or was it an abrupt collapse of the society? So we'll see later on. There is a paper that argues that archaeological evidences actually do not necessarily support the idea of societal collapses, that this kind of alarmist messages about climate-driven migrations and societal collapses are not consistent with the evidences that these kind of transitions out of prosperous civilizations tend to happen much more gradually. So this question of whether climate is a proximal driver or the ultimate driver of societal changes in the context of agriculture here will continue throughout. And this shows that, again, if we look at the same period, there is clearly a CO2 signal there. I won't read the long caption, but here we are going from 10,000 years ago into the pre-industrial period. So coming out of the last glacial maximum, we were at around 267 ppm or so. To the pre-industrial period, we increased to 285. Remember, during the last glacial maximum, it would have been below 200 ppm, and there is also a methane variation associated with that, but methane is not as monotonically increasing as CO2 did, because you had associated with the rainfall changes and so on, you would also have changes in wetlands, agricultural lands. Rice paddies were not as dominant as now. Livestock were not as dominant as now, so you would have methane increasing now rather monotonically. Now we are at, I think, 1700, over 1700 pp parts per billion by volume. So I'm sure you are aware this is parts per million, whereas this is parts per billion. And also the sources of methane you can see here, depending on what period you are looking at. Let's read here. Solid bars represent the tropical source, so 30 south to 30 north, and shaded bars represent the source of middle to high northern latitudes, so 30 to 90 degree north. Was assumed to be constant over the Holocene period of 15 teragram per year. So this is modeling exercise. Comparison of the long-term trends of methane, N2O. N2O is here. So you can see that N2O also had not such a linear increase, and again that's also in parts per billion by volume. Comparison of the long-term trends of methane and N2O to the CH4 source distribution for the above mentioned time periods show that Methane was mainly controlled by drying of the tropics, while N2O seems more related to the middle to high northern latitudes. Not shown are the source distribution calculations for the time period of 0.25 to 1 kiloyear, because tentative results deduced from gradient between Dome Sea and GRIP methane measurements indicate a different source distribution than found in this paper that's mentioned here. So depending on the period of the Holocene, you have different levels of tropical and mid-latitude to high latitude sources of methane. So during the climatic optimum, you can see here, as the drying and cooling started, the tropical source became large, and when we came out of the last glacial maximum, rainfall distribution was we were still in relatively cool temperatures, and the rainfall had not picked up, which happened in these periods. So here the tropical forest sources were significantly larger than the mid to high latitude sources. So this just tells you the complications of inferring human activities and human impacts. Talking of that, we can look at some evidences of other human impacts from this book, which is Natural Climate Variability and Global Warming, a Holocene Perspective. It shows human-induced changes. Will Steffen tends to write a lot of papers on human impacts along these timescales as well. So the water erosion, again we are going here from 4000 BC to 2000 AD. So this terminology will continue in some papers, because these are older papers where we talked about Anno Domini and before Christ, whereas it got changed to Common Era and before Common Era to be more secularist, I suppose. So you can see soil leaching and water erosion. So this is increase, relatively speaking, higher compared to modern periods. So some of the human-induced changes inferred from multidisciplinary ESTAD project in southern Sweden. So this is not global. So this is less than modern. So we started here 4000 BC, increased quite significantly. Similarly, soil leaching, and these estimates will keep coming along. Populations in thousands. Coming here for this region, 4000 BC to 82,000. You can see in the 19th and 20th centuries, significant increases still associated with lifespan changes, fertility rates, agriculture, availability of cereals, either via imports or local production, and so on. Deforestations, so you can see woodlands and openlands. Woodlands decreased, so deforestation increased, and open lands increased in terms of biotic response, which again we will look at from various sources for different regions. Fire impacts, not very easy to explain, but you can go and find literature that explains these things as well. This is still a big problem. Portugal and Spain as of 2022 are having massive heat waves and wildfires. US always has lots of wildfires as well. Australia has had wildfires. So there is a complex interaction between humans trying to control fire and global warming and drying, exacerbating the potential for fires, if not in terms of the number of fires, but in terms of the areas burned and intensity of fire, and so on and so forth. Arable land, of course, increased as agricultural activities increased, especially since in the Common Era, and lake eutrophication, which corresponds to growing human settlements in the older periods, and accumulation of human waste, and maybe concentration of nutrients through agricultural activities. And there is some argument that wild crops actually began to settle down around human settlements because of the fertilization of the soil by settlements, the humans who were fertilizing the soils with their waste. So that could have led to ideas about domesticating crops as well. Okay, so this is actual and inferred natural trends of atmospheric concentrations of CO2 and methane during the Holocene. Bill Ruddiman works on this a lot, and his idea is that human impact has been obvious throughout the agricultural period or the Holocene. The histograms ascribing methane to different source regions during the Holocene are shown here again. So we are here now looking at south, which remains small throughout the period. Tropics, which have decreased over this period here, and north has increased. So that's methane sources. So solar radiation forcing of course has been a factor in the greening of Sahara monsoon changes, and here what the natural methane trend based on orbital forcing would have been, but observed methane has gone this way since the middle of the Holocene, end of the Holocene climatic optimum, for example. And so there is a signal of 250 ppb, which Ruddiman says is related to human activities and significantly away from what would have been a natural trend. So you can imagine that anthropogenic impacts already were manifest according to this interpretation. And similarly, CO2 coming out of the last glacial maximum, natural peak happened as solar radiation was decreasing at the precessional time scale, which is the biggest forcing in the monsoon variability. Nice work there by John Kutzbach and Zhengyu Liu and so on. So natural trend would have been expected to go this way, but over this period there is a 40 ppm signal in observed CO2, which Ruddiman attributes to human agricultural activity, population growth, deforestation, and so on. So this kind of idea is also extended by Ban and Eleni's conceptual model of the interactions between human activities and their environment that could have led to the dramatic population decline on Easter Island, which is a poster child for how far human impacts can go in destroying an island in many ways. The shaded boxes identified processes and interactions that are less specific to Easter Island. I want to read through the whole thing, but you can see you can start anywhere. Population decline is what we are talking about. So if you start here with forest clearance for agriculture and firewood, which is common for most regions that we will discuss, there is soil exhaustion and erosion. More land is needed for agriculture, which drives positive feedback to forest clearance. Human population grows as you produce more food, which can lead to militarization and warfare and crop destruction, which again demands more food and more land clearance. And here soil exhaustion and erosion can lead to insufficient good land, arable land, for agricultural production and population decline. And there are a bunch of other feedbacks through rodent population, seabirds, seafood resources, eating of bird eggs by rodents, and so on and so forth, that I will not go into. But this is a story that has been discussed in many papers and books in terms of the change in vegetation, decline of statue building, which was an indication of society's establishment, growth, governance, power, militarization, and other things. So decline of fishing rodents, which affected forests, which feeds back to forest clearance and agriculture, and so on and so forth. So if we look at the drivers, pressure, state, impact, response conceptual framework, in this case you can again start anywhere, but drivers include climate and socio-economic change, not necessarily the immediate causes, but can be ultimate causes, which is argued even for the 20th and 21st centuries in terms of situations in Syria, Middle East, Somalia, Sudan, elsewhere, Rohingyas, etc. So that puts pressures on environmental and economic activities. So environmental state changes are brought about, which then can affect coasts, land water, and biodiversity, which typically lead to policy or autonomous responses, which again put pressures or alter pressures on environment and economic activities and affect drivers like climate and socio-economic change. In other words, we will look at many examples of human activity throughout the Holocene. Agriculture is kind of the focus, so we'll look at lots of agricultural activities, informations, crops, adaptations, and so on. But climate and society, climate and humans are kind of the running theme as well, because agriculture, food production, militarization, social structure, population will all relate to agricultural activity as well. So we will not always specifically say agriculture, but you can imagine agriculture is always a background driver throughout this chapter. Okay.